Welcome to the next lesson in our combining functions unit. We're going to introduce composite functions again. You probably have seen this before in grade 11 pre-cal. We're just going to continue on with this in grade 12 pre-cal. So your definition of composite functions, if you're given two functions, let's say f and g, the composition of f and g is f of g of x or f, a circle, g of x. So both expressions can be read as f of g of x. In other words, composite functions are functions inside a function. Please take the time and copy down these few sets here for your x and your g of x and f of x. So your input is your x, and we're going from -2 to 2. And then g of x and f of x, those are like your y values for that specific function. So go ahead and copy that down, and then we're going to find f of g of -1. So to find f of g of -1, the first thing we're going to do is find the inside function, which is g of -1. This is our first arrow diagram, because that's the one that describes g of x. So g of -1, -1 is our x value. If I follow this along, looks like it's going to be 2. So g of -1 is 2. Now if I want to find f of g of -1, well, I just found what g of -1 is. I'll replace this g of -1 with 2. Now I'm going to look at the next arrow diagram. So use the second arrow diagram. To find f of 2. So 2 is our x value. If we input 2, we're going to get back a 3. So f of 2 is 3. So therefore, your final answer for f of g of -1 is 3. Now we can also do this in a table of values. It's very similar. If we're trying to find f of g of -1, we need to find g of -1 first. G of -1, so -1 is here, and I want the g of -1, and according to our chart, that's going to be 2. So I can replace g of -1 as 2. Then I'll evaluate f of 2. So x is equal to 2, and if I put it into an f, I'm going to get back 0, and that will be our final answer. First thing we're going to do is look at f of 1. f of 1 is over here. That's your x value is 1, and we're going to insert into f, and we're going to get back a -1. So this is f of -1. And then looking back at -1, and I'm inserting it back into f, I'm going to get 3. So our final answer then is 3. In this next example, we're going to read it off of a graph. So the green is g of x, the red linear graph is f of x. We need to find g of 1 first. So the x value is 1. And we're looking for the y value of our green graph, which is g. Looks like it's this part right here, which is at 4. So replace the g of 1 with 4. Now looking at the red graph, we're looking at x equals 4 and seeing where it hits on our red graph. Looks like it's at 1, 2, 3, 4, 5. For our next one, we're actually going to find g of f of 1. Sorry, that's a typo there. So we're going to look for f of 1 first. f of 1 is located over here. And our y value is going to be -1. So then we're looking at g of -1. And then at g of -1, we're going to get our point down here, reading off of the green graph, it's -5. Our y value is -5, and that's our final. To find when f of x is equal to g of x, we're looking at the intersection points, and I already circled them here. This occurs at x equals -1 and x equals 3. Remember, we only care about the x value, do not state any y values. Moving on to the next example. We want to find f of g of 2. So I'm going to replace g of 2 with the function of g, but instead of writing x squared, I'm going to write 2 squared because the 2 replaces the x. Now I'm going to simplify what's in the bracket. 2 squared is 4. So over I'm looking at f of 1/5. Now I'm going to insert 1/5 into the x for the f of x function, which is the absolute value of x, in this case is 1/5 minus 1. We could also simplify this so we can get our final answer. And I do need to have a common denominator to subtract our fractions. So 1 can be replaced with 5/5. So I'm going to get -4/5 in the absolute value. Then the absolute value of -4/5 is 4/5. Now let's do this for g of f of 2. So my f of 2, my f function is absolute value of x minus 1, but in this case I'm going to put 2 in for my x. Let me just simplify this. So 2 minus 1 is 1, absolute value of 1 is 1, so I'm looking at g of 1. My g of x function is 1 over x squared plus 1, but my x in this case is just 1. So our final answer is 1/2. I want you to try the next one on your own, and then when you're ready, press play for the solution. Okay, so this one's a little long. You might be tempted to use your calculator here, and that's fine. So you have f of g of 9. So we're going to calculate g of 9 first. So the g is -2 times x. In this case, our x is 9, and then plus 1. I'm going to simplify this. So we're looking at f of -17 then. Then we're going to insert this into our f function, which is x squared plus 3x. Instead of putting the x in there, I'm going to write -17 in for the x instead. 17 squared is 289. It's going to be positive, minus, and then 3 times 17 is 51. So then we're just going to subtract the 2, which is 238. I'm going to do something similar for the next one. So f of 9, I'm going to plug the 9 into my f function. So that's 9 squared plus 3 times 9. 9 squared is 81. 3 times 9 is 27. And then 81 plus 27 is 108. And then we're going to plug in our 108 into the g function, which is -2 times x, or x in this case is 108, and plus 1. -2 times 108 is -216, then plus 1, our final answer is -215. In our next example, we want to find the composite function of each, and we're just leaving it in terms of x. We also want to find the domain. Don't worry about the range because you wouldn't need to really find that on the exam anyway. Okay, so f of g of x. Our g of x is 3x minus 5. And then our f of x is x squared plus 3x. But instead of writing the full just x, I'm going to write the 3x minus 5 in for that x. Okay, so I'm plugging this 3x minus 5 into each x here. Now I'm going to simplify. That's 3x minus 5 times 3x minus 5, which is 9x squared minus 30x plus 25 plus 9x minus 15. So I again multiply 3x minus 5 times 3x minus 5, and I distribute this 3 to each term in the bracket. Now I'm going to simplify. Negative 30x plus 9x is negative 21x, and 25 minus 15 is 10. And that's our final function for f of g of x. Our domain, this is a quadratic, so that's from negative infinity to positive infinity for our domain. For the next one, our f of x is x squared plus 3x. I'm going to put in x squared plus 3x every time I see an x in my g of x function. So that's 3 times x squared plus 3x minus 5, which is 3x squared plus 9x minus 5, and that's our final answer. Our domain, this is quadratic again, so it'll be negative infinity to positive infinity. Lastly, for f of x is x squared plus 3x, and then we're going to plug x squared plus 3x into x squared plus 3x. So that's x squared plus 3x to the power of 2 plus 3 times x squared plus 3x. We're going to simplify this. So this will be x to the power of 4 plus 6x cubed plus 9x squared, and then 3x squared plus 9x. So our final answer then would be x to the power of 4 plus 6x cubed plus 12x squared plus 9x. This is a polynomial, so our domain could be anything in the reals. So do the try it yourself on your own, and then when you're ready, press play for the solution. So we're going to insert our g of x into our f of x. Our g of x is 2x plus 1. For our f of x, that's 2. I'm going to insert 2x plus 1 in there, square it, because that's part of f of x, plus 1. And then we're going to simplify. So 2x plus 1 times 2x plus 1 is 4x squared plus 4x plus 1. Then we're going to multiply by 2 in those 3 terms, which is 8x squared plus 8x plus 2 plus 1. This is 8x squared plus 8x plus 3. Our domain is going to be negative infinity to positive infinity because this is a quadratic. For g of f of x, our f of x is 2x squared plus 1. Our g is 2 times whatever was in that bracket, then plus 1. Multiply this is 4x squared plus 2 plus 1. Final answer is for x squared plus 3. Our domain is negative infinity to positive infinity because this is a quadratic. Lastly, our g of x is 2x plus 1. And we're going to do it again. I'm going to insert 2x plus 1 in for that x, and then simplify. So 2 times 2x is 4x, 2 times 1 is 2. Our final answer is 4x plus 3. This is a linear equation which has a domain of negative infinity to positive infinity.